So today we're going to be discussing solving systems of equations with substitution part 1. Number 1, Jessica and Tyrone are both saving money. Jessica starts with $100 and saves $10 per week. Tyrone starts with $60 and saves $30 per week. When will they have the same amount of money and how much will they have? Well, let's take some important information. We want to let x equal the number of weeks and y equal the amount saved. So I'm going to start with Jessica starts with $100 and saves $10 per week. Well, she starts with $100, so that's going to be the y-intercept. So that's going to be plus 100. And then it's $10 per week. So it's 10, and we don't know how many weeks that is, so we're going to represent that with x. So the equation for Jessica is y equals 10x plus 100. Then we have Tyrone. Tyrone starts with $60 and saves $20 per week. So $60 is the starting amount, so that's going to be our y-intercept, or b value, and it's $20 per week, so that is 20x. So those are our two equations that we're going to be working with. Jessica's is the top, Tyrone's is the bottom. If it helps, you can always put in that extra information. By Jessica, y equals 10x plus 100. And then for Tyrone, y equals 20x plus 60. So we're going to solve this using the substitution method. So a substitution method is the same idea of if you play a sport or in a band and you need someone to substitute in for you or sub in for you, that means that instead of you playing, they're going to take you out and they're going to put in someone who plays the same position as you or the same instrument. So step number 1 is to combine the two equations into one equation with just one variable, and we want to then solve for that variable. So I'm going to rewrite both equations. Y equals 10x plus 100 and y equals 20x plus 60. So we want to identify a term that is already by itself, meaning an x or a y term. If there's not an x or y term by itself, then we have to make one. So for the first equation, it says y equals. I'm going to pause right there. The y is by itself. Well, let's just double check. Anything in the second equation? Well, it says y equals again. So that y is by itself. So what we're going to do is we're going to take the y from our first equation. The y from our first equation is this 10x plus 100. And we're going to substitute it in for the y in our second equation. When we do that, this becomes 10x plus 100 equals 20x plus 60. So you'll notice in blue that my 10x plus 100 is replacing my y in the second equation. But you'll notice in black, my second equation is still 20x plus 60 on the right side. So we only have the x variable that's left. Therefore, we're going to solve it. Now I'm going to rewrite this 10x plus 100 equals 20x plus 60 off to the right to ensure I have enough room. I'm going to extend my equal sign. I want to combine my like terms. So I'm going to start off by subtracting 20x from both sides. Now, you don't have to start in that order. It's completely up to you. That's just what I'm choosing. So 10x minus 20x gives me negative 10x. Plus 100 equals 20x minus 20x is 0 plus 60. So that is negative 10x plus 100 equals 60. Next, I'm going to subtract 100 from both sides. This leaves me with negative 10x equals negative 40. On both sides, I'm going to divide by negative 10. Again, this is to get my x variable by itself. So I get x equals 4. For step number 2, we're going to solve for the other variable, meaning if we have our x value, we now want to solve for our y value. You can pick either of the original equations to plug it in, to plug the x value into. Doesn't matter which one. I'm going to choose the first equation, y equals 10x plus 100. But again, you could have chosen y equals 20x plus 60. It won't matter. So I know x equals 4. So instead of putting the letter x, we're going to replace it with the number 4. So y equals 10 times 4 plus 100. Y equals 40 plus 100. Y equals 40. Let's say, for step number 2, you instead want to use the other equation. Y equals 20x plus 60. So this is step 2. I'm just going to show the work, just in case you chose that one. I'm still going to replace x with 4. So y equals 20 times 4 plus 60. Y equals 80 plus 60. Y equals 140. Now I realized that I did not add correctly with my other equation. All on accident. 40 plus 100 is 140. I sure hope that you guys realized that and caught that. So, part of step 2 is to write your final answer as the ordered pair. My x value is 4. My y value is 140, not 40. So this is going to be my solution. I use substitution rather than graphing. Certain problems, substitution is simpler than graphing, such as this, where you have values such as the y being 140. Number 2, we have a system y equals 100 minus 30x and y equals 40 minus 10x that represents the lamp inventory at 2 different stores. We're going to solve the system with substitution to find out when the inventory is the same. So I'm going to rewrite that system. Y equals 100 minus 30x and y equals 40 minus 10x. I use the bracket out in front, just like we had in the previous problem up here. Okay, so the first step is to make sure that we have one of our equations where the variable is isolated, either the x or the y. Then we'll substitute that value into the other equation. So the first equation, well, we actually already have y by itself. In fact, the second equation, the y is by itself as well. So what I'm going to do is I'm going to take my y equals from the first equation, and I'm substituting it in to my second equation. 100 minus 30x. That's subbing in that y in the second equation with the first, equals 40 minus 10x. Now I'm going to solve this normally. Extending my equal sign. You can combine your like terms however you want. I'm going to start by adding 30x to both sides. So that becomes 100 equals 40 plus 20x. I'm going to subtract 40 from both sides. I get 60 equals 20x. I'm going to divide both sides by 20. 3 equals x. So that means that x equals 3. All right, I have my x value. Now I need to move on to step number 2. We have to solve for the other value. So in this case, we need to solve for our y. Again, doesn't matter which equation you choose. I'm going to choose the second one because it has smaller numbers. I like to make my calculations easier. So y equals 40 minus 10x. I'm going to substitute in 3 for my x. Again, I got my 3 from step number 1. So the equation becomes y equals 40 minus 10 times 3. So y equals 40 minus 30. Y equals 10. So the ordered pair is 3, 10. Now, We need to go back and explain that because it says, solve the system with substitution to find out when the inventory is the same. Well, 3 comma 10, so that means after 3 weeks, each store will have 10 lamps left. All right, let's move on to on to page number 8. Numbers 3 through 6. We're going to solve each of these with substitution. First step is to ensure that our equation has at least one where the y or x term is by itself. If you notice, our y terms in both of them are by themselves. So I'm going to take the y from the first and replace it in with the second. 2x plus 3 equals 4x plus 4. Solve my equation. I'm going to subtract 2x from both sides. 3 equals 2x plus 4. Subtract 4 from both sides. 3 minus 4 is negative 1 divided by 2x. Divide both sides by 2. X equals negative 1/2. Now we need to take one of the equations and substitute my x value in to get the y. Again, it doesn't matter which one. I'm going to choose the first equation this time. Y equals 2x plus 3. Again, the numbers are slightly smaller. And I'm going to plug in x equals negative 1/2. So y equals 2 times negative 1/2 plus 3. 2 times negative 1/2 is negative 1 plus 3. Negative 1 plus 3 is 2. Breaking down the left side, y equals 2. Because this isn't a word problem, I just write my answer as an ordered pair. Negative 1/2, comma 2. Problem number 4. Y equals 3 minus 2x. Y equals 2 minus 3x. If you notice, step number 1, we need to isolate one of the variables, which the y's in both of them are isolated. So I'm going to take the y from the first equation and substitute it into the second equation. 3 minus 2x equals 2 minus 3x. Well, there's subtraction in both of these, so I'm going to go and add the opposite and make it adding a negative 2x, and add the opposite and make it negative 3x. I just rewrote it, make it a little easier to see. All right, so I'm going to combine like terms. I'm going to add 3x to both sides. 3 plus 1x equals 2. Subtract 3 from both sides. That becomes 1x equals negative 1, or x equals negative 1. Now I need to solve for my y. Again, it doesn't matter which equation you use. I'll just use the first one. Y equals 3 minus 2x. I know that x equals negative 1. So I'm going to take this negative 1 and plug it in there for that x. Y equals 3 minus 2 times negative 1. As a reminder, I'm going to add and make that into a negative 2. So negative 2 times negative 1 is 2. 3 plus 2 equals 5. I bring down the left side. Y equals 5. So my ordered pair is negative 1, 5. Problem number 5. Y equals 2x plus 6, and y equals negative 2x plus 4. You'll notice that the first equation has the y isolated, as well as the second equation. So I'm going to take this 2x plus 6 and I'm going to plug it in for y. So 2x plus 6 equals negative 2x plus 4. I'm going to change the color of my right side of the equation, just to indicate that is my second equation. All right, now I'm going to go and solve it like normal. I'm going to add 2x to both sides. That leaves me with 4x plus 6 equals 4. Subtracting 6 from both sides, I get 4x equals negative 2. I'm going to bring that up over here to make sure I have enough room. So 4x equals negative 2. I'm going to divide both sides by 4. X equals negative 1/2. This time I'm going to use my second equation. Y equals negative 2x plus 4. And I'm going to use x equals negative 1/2. So y equals negative 2 times negative 1/2 plus 4. Y equals, well, negative 2 times negative 1/2 is a positive 1 plus 4. 1 plus 4 is 5. I bring down my y. Y is 5. So my ordered pair is negative 1/2, 5. All right, number 6. I'm going to rewrite that second equation below. Y equals negative 3x plus 2. Just so then it's set up the same way, and I can see it. All right, so my y from my first equation is isolated, as well as my second equation. So I'm going to take this 3x minus 4 and I'm going to plug it in for y. So 3x minus 4 equals negative 3x plus 2. Well, this says minus 4, so I'm going to make it into negative 4 and start by adding 3x to both sides. 6x plus negative 4 equals 2. The zero pair of a negative 4 is adding 4. Is it positive 4? So the left side is 6x equals 6. Divide both sides by 6. X equals 1. Now we need to solve for the y. I'll use my first equation again. Y equals 3x minus 4. Could have used the second one. X equals 1. So I'm going to take this 1, I'm going to plug it into that x value. Y equals 3 times 1 minus 4. 3 times 1 is 3 minus 4. 3 minus 4 is a negative 1. I bring down my y. Y equals negative 1. So that means that negative 1, oh, I apologize. It means that 1, negative 1 is my final answer.